Good morning. Today we're continuing our unit on radicals, and we're going to look at some more multiplying, dividing, and simplifying of radicals. It says here you can use the product and quotient properties of square roots together with commutative, associative, and distributive properties to multiply, divide, and simplify square root radicals. Practice. Assume all variables represent positive real numbers. Okay. So now that it's saying assume that all variables represent positive numbers, that tells us if we have a variable, we don't have to worry about absolute value symbols with your variables. So I'll make sure we talk about that if we have any of those. All right, so what does this look like? What makes this different than what we've already done? So if we have the square root of 3 times the square root of 6, because they are both the square root, you can multiply what's inside the radical. So this gives you the square root of 18. Okay, now that you've done the square root of 18, you go back to your simplifying. Are there any factors of 18 that are perfect squares? And yes, there are. 9 is a perfect square, so I'm going to break this down to the square root of 9 times 2. 9 is a perfect square. It's 3, but 2 is not, so it stays under the radical. So I get 3 times the square root of 2. Here's another one. 7 square root of 2 times 5 square root of 2. Okay, so we have numbers in front of our radicals. Those can be multiplied. So 7 times 5 is 35, and then they're both square roots, so 2 times 2 is 4, and we know that 4 is a perfect square, so this becomes 35 times 2, or 70. The next one, the square root of 7 times the square root of 42. Okay, so I look at this, and you can do this a couple ways. When I think of 42, I think of two factors. I think of 7 and 6. So I'm going to take the first square root of 7, and then I'm going to break up 42 to 7 times 6. Why? Because if it helps you, 7 times 7 is 49, which is going to tell you that that's a perfect square, or you can just cross through both of the 7s and know that that's going to just be 7 when you take the square root of it. So the square root of 49 is 7. 6 does not have any other perfect square factors, so my answer is 7 times the square root of 6. So you can see how I'm using like little tricks to help me out to try to find perfect squares when we're having to multiply together. All right, I have the square root of 8 times the difference of 7, the number 7, and the square root of 14. All right, so I'm going to go ahead and distribute because it said we can distribute. The square root of 8 times 7 is 7 square root of 8. Don't make that the square root of 56. One's a radical, one is not. Now, the square root of 8 times the negative square root of 14 you can combine together, and that would be negative square root of 112. Okay, so now I'm looking for factors of 112 that would be perfect square factors, and I know 16 and 7. So when I write this, I have 7 square root of 8 minus the square root of 16 times 7. Square root of 16 is 4. So I have 7 square root of 8 minus 4 square root of 7. Now, if I look at the square root of 8, we haven't talked about that yet. There is a perfect square factor in there. What factor? It's 4. Oops, switch it back. So that becomes 7 times the square root of 4 times 2, and that's a 2. So that's coming out front to be multiplied with it. So I get 14 square root of 2 minus 4 square root of 7. I cannot combine those together because I do not have like radicans. So that's my answer. All right, let's go to number 5. The square root of x times the difference of the square root of x minus 3. All right, distribute the square root of x times the square root of x. X times x equals x squared minus 3 times the square root of x. We can't put those both under the radical because one has a radical and one does not. If you remember from the last lesson or from what we've done before, the square root of x squared is x, right? Because it's even. So you take half of that. Now before, because it was odd, when you took the square root, you had to put it in absolute values. But because they told you assume all variables are positive numbers, you don't have to worry about that anymore. So we have x minus 3 times, did it again, 3 times the square root of x. We cannot combine these. That's all you can do. So you're done. Number 6, 3 times the square root of ab squared times negative 2 times the square root of a. All right. So this tells us we have a 3 and a negative 2. We can multiply those and get negative 6. In the radical, they're both square roots, so I have the square root of a, b squared times the square root of a. That's going to give me the square root of a squared, b squared. Both of these are perfect squares, so this becomes negative 6ab. And again, even though they're odd exponents, because we were told that to assume that all variables were positive, we don't have to worry about it. Okay, what do we have here? This one looks like a longer problem. So it looks like we have 3 times the square root of 8 times negative square root of 6 times 4 times the square root of 15. All right, so we're going to take everything on the outside first and multiply it. 3 times negative 1 times 4. That's going to be negative 12. And then we're going to multiply what's under the radicals. And when we do that, we get 15 times 6 is 90, times 8 is 720. 720. So again, don't know if this is a perfect square, but I can try to do some factors. It ends in a 0. So I think I'll try 5. And when I do, I get negative 12 times 5 goes into 7 once. With 2 left over, it goes into 24 times, or to 22 4 times, and into 24 times. Okay, so I did that mentally, and I know that that's a perfect square, so I'm pulling that out front. So now I have negative 12 times the square root of 5, which is negative 144 square root of 5. All right, we're going to do one more in this section, and then we're going to move to the bottom part. Number 8. Ooh, this is good. 3 times the square root of 6x squared. So let's talk about this. The whole thing's in parentheses, okay? It means we're squaring the whole thing, okay? So 3 squared. And you can square what's under the radical, or you can know that it takes, when you square something that's in a radical, it takes that out. So let me write that way. So you can do it a couple ways. All right, 3 squared is 9. And I know when I square something that has a radical, it takes it off. So I end up with 9 times 6x, or 54x. If you want to go ahead and put that as 36x squared and then take the square root, you're going to be right back at 6x. Okay. All right. Now let's talk about when a radical is in simplest form. It's in simplest form when no radical has a perfect square factor other than 1. There's no fractions under the radical sign, and there's no radicals in the denominator. You can eliminate a radical from the denominator by multiplying a rational expression by the appropriate value of 1. All right. So let's see what all this says. All right. Number 1, 3 divided by the square root of 5. Okay, there's no perfect square factors in 5. there is not a fraction under that radical, it's just a 5. But there is a radical in the denominator. So we're going to be using this right here where it says you can eliminate a radical from the denominator by multiplying by the appropriate value of 1. So I am going to multiply the numerator and denominator by the square root of 5 so I can get rid of that radical. Remember, the square root of 5 over the square root of 5 is really 1 because we're doing the same thing. So what do we have in the numerator? 3 times the square root of 5, because you cannot multiply those. One's a radical and one's not. Over the square root of 25. What is good about that? Well, 25 is a perfect square. It eliminated the radical. So we get 3 square root of 5 over 5. We cannot cancel anything because the 5's in the radical in the numerator. It is not in the radical in the denominator. So that's as far as we can go. If there was, say, 10 times the square root of 5 over 5, you could have simplified the 5 and 10. Okay, let's go to the next one. The square root of 7/8. All right, it says that no fractions under the radical. Well, that's not true. We do have a fraction. So first of all, we're going to break it up. So it looks like that. The next thing says no radicans have a perfect square. I kind of reversed those. There's no perfect squares in 7, but 8 has a perfect square. Remember, 8 is 4 times 2. So this is going to be the square root of 7 over 2 square root of 2. Okay, because that's a perfect square. Now, the third thing says there's no radical in the denominator. To get rid of the radical in the denominator, I just multiply by whatever that radical is in the denominator. Just like I did in number 1, I multiplied by the square root of 5 to get rid of it because it's going to make it a perfect square. All right, so now in the numerator, I have the square root of 7 times the square root of 2. That's the square root of 14. I can multiply those together. In the denominator, I have 2 times the square root of 2 times the square root of 2. This I can multiply. It becomes 2 times the square root of 4. And what is the square root of 4? It's 2. So I end up with the square root of 14 over 4. I cannot simplify those because 1 is a radical and 1 is not. All right, the next one. 9 times the square root of 3 over the square root of 24. Okay, so let's see, we have the square root of 24 in the denominator, and we know that it has a perfect square factor in it because 4 times 6 is 24. All right, so we're going to go ahead and pull that out front, or just take that square root, so it becomes 2 square root of 6. Now, we can't have a radical in the denominator. What are we going to multiply by? The square root of 6 over the square root of 6. When I do that, I get 9 times the square root of 18 over 2 times the square root of 36. 36 is a perfect square at 6, so this becomes 12 in the denominator. 18 has a perfect square factor. I'm just going to write it above here. 9 times 2. I take that out, and that becomes a 3. Remember, the square root of 9 is 3, so I have 27 square root of 2 over 12. Now, do these share a common factor? They do. They sure do. They both share a common factor of 3. 3 goes into 12 4 times, and into 27, 9. So this becomes 9 square root of 2 over 4. Okay, I'm going to stop there because we're almost out of time, and we literally have one more problem to do after this, but that's okay. I'll come back on.